In the comments, you often ask to check what will happen if water is compressed in a closed container with a hydraulic press. Probably, if you compress water, not much interesting will happen, but if the water finds a way out, then something interesting will begin. We have already checked what happens if you compress an oxygen cylinder filled with water and the force of a chaotically directed jet of water released at a pressure of about 500 atmospheres. At a speed comparable to that of a bullet, it easily tears through the protective screen made of 3 mm monolithic polycarbonate, which no metal flying fragment had previously managed to break. Today we will check how dangerous water can be under enormous pressure. I had this kind of structure made to order. At first glance it looks like a few simple metal pieces, but it's not that simple. This is a special Hone tube used to make hydraulic cylinders that operate under ultra-high pressure. The maximum allowable pressure is 1500 atmospheres. By itself, this is quite an expensive item. All these metal parts cost me 20,000, with 80% of that cost being the price of this Hone tube. And a piston with a sealing ring. Moreover, the sealing ring, custom ordered from the Czech Republic, is designed for a pressure of 1000 atmospheres. There are also several nozzles with very small openings through which water will burst out under enormous pressure. Knowing the load we will apply, it is not difficult to calculate the pressure inside the container. Knowing the diameter of the piston, we determine its area, and by dividing the maximum load by the area, we find the maximum pressure that was in this container. For example, with a load of 10 tons, a pressure of 510 atmospheres will be created inside. Well, it's time to start the experiment. Let's screw in a nozzle with a diameter of 1 mm, slightly tape it with electrical tape so that the water doesn't flow out by itself. We'll fill the container with water and first check if the water can cut through the cardboard used for business cards. This is quite dense cardboard. The maximum load that we had was 137 kilograms, which corresponds to a pressure of only 7 atmospheres. And 7 atmospheres is kind of nothing. I thought we could somehow develop more pressure. Well, let's take the smallest nozzle with a diameter of 0.6. In this case, the load was already 750 kilograms, which corresponds to a pressure of 38 atmospheres. Honestly, these figures disappointed us. The fact is that during the design stage, it was not possible to calculate this entire structure as our press is custom made and some of its characteristics, such as the piston speed at maximum load, are unknown. Accordingly, there could be no question of any calculation. But after the experiments, only one thing was clear. To achieve significant pressure, the diameter of the jet needed to be significantly reduced. Ideally, this opening should be made with a diameter of 0.1 millimeter. But, as it turned out, this is not very simple. Not a single production workshop took on such work, if only for the reason that they simply did not have such a drill. Have you ever seen what a drill with a diameter of 1/10 of a millimeter looks like? Why? Let's say, not the most common item for sale. We had to order a set of such drills from China. A month of waiting and we have the drills. The diameter of the drill is comparable to the thickness of a human hair. This is what the drill looks like at 80 times magnification. This thick tube next to it is a needle from a medical syringe. And this is how a human hair compares to a 0.1 drill bit. It has almost the same thickness. How interesting it is to drill steel to a depth of about 1 millimeter with such a drill. That is essentially to a depth of 10 diameters of this drill. For this, it was necessary to construct a small hybrid, a hybrid of a dental drill and a microscope. Such a miniature drill was purchased along with a simple microscope stand, and by combining them, this miniature drilling machine was created. And even with the help of such a custom machine, it didn't work out very well. In general, during the drilling process, we broke a bunch of drills. We couldn't drill a hole with a diameter of 1/10, but we managed to make two jets with diameters of 0.4 and 0.2 millimeters, respectively, and we were very pleased that we managed to drill a 0.2 millimeter hole. So, let's first try to see what pressure we can achieve with a nozzle of 0.4 millimeters. The maximum load was just under 3.5 tons, which corresponds to a pressure of 170 atmospheres. But that's at least something more interesting. Water under such pressure easily pierced cardboard. And now let's see what water with a 0.2 millimeter jet can do. Let's use an apple as the test sample instead of cardboard. The maximum load was 14.5 tons, which corresponds to a pressure of 740 atmospheres. The water easily pierced the apple and even tore it a little. And now let's see what happens if we place a gas lighter under this powerful stream. By the characteristic release of bubbles, we can conclude that there is a gas leak, and with the stream, by the way, we hit the strongest part of the lighter, the plastic rib located in the very center. Let's place this same lighter under the same stream, but with the other side though. In slow motion, you can see that the water jet pierced the plastic wall of the lighter. Through the pierced hole, the water entered inside. The filled the lighter. The pressure inside increased accordingly, and the lighter shattered to pieces. In general, water under enormous pressure has quite a significant force, and this is considering that the diameter of our stream is only 0.2 of a millimeter. By the way, water at approximately the same pressure, kocma pressure, but with a jet about a millimeter in diameter, can easily cut metal. Industrial water jet cutting machines can cut steel up to 30 centimeters thick. Neither plasma nor laser can achieve this. The water pressure in such installations can reach 5,000 atmospheres. Suggest in the comments which objects you would like to see under the hydraulic press, and be sure to subscribe to the channel if you haven't already.